Sketching in mid-air is a promising way for novices to create 3D models. Unlike in virtual reality, augmented reality lets us directly trace the shape of a physical object with a pen while modeling, thereby benefiting from the natural haptic feedback objects provide. This tracing is useful for personal fabrication, for example, to create an object that fits inside or around an existing one. We first classified the properties of objects that let users trace along them, and then studied how they impact users' performance. Since augmented reality allows to place purely virtual objects in the real world, our initial distinction is whether the object to sketch on offers a physical surface or is completely virtual. Other aspects guide the users towards performing a stroke along a particular feature of the object. This feature can be defined by surface markings such as this illustration on a book. The shape of an object can also guide the user. For example, the form of this paper tray creates a concave edge on the inside. The user can trace this edge assisted by strong physical constraints. Similarly, this convex edge also defines a line to follow, but the physical constraint is not as strong and allows users to slide off the edge. We performed a study to quantify the effects of these different guidance types. For this, we synchronized a motion tracking system with an AR headset. This way, users could see their virtual strokes directly on the object. We asked participants to sketch around both physical and virtual objects with features sampled from our classification. For each stroke, we calculated the deviation overall, in the horizontal direction and in the vertical direction. We found that participants deviated almost twice as far while sketching on virtual objects. While a physical surface has the greatest impact on accuracy, any form of guidance lowers the deviation from the optimal stroke. Especially on physical objects, all line guidance types improve the accuracy in the vertical direction. Furthermore, our results suggest that for the virtual objects, users drew above the target line in the vertical dimension, while drawing slightly lower than the target line on the physical objects. We also found that users seem to sketch more accurately on the sides than on the front and back of virtual objects. Our results provide initial metrics for designers of AR sketching systems.